All right. So now let's talk about how to insert something. And you might say this is a pretty patchy tree, right? But the reason I think whoever made the slide, which wasn't me, made the slide this way, is because the tree is just big and we're ignoring the parts that we're not focused on, right? So everybody, in your own mind, search for 10. And when do you discover it's not there? Right? Everybody see where 10 goes? We're at 1. 10 is bigger. 10's bigger than 3. 10 is smaller than 11. 10 is bigger than 9. Oops, it needs to go there, right? So what do? Is we find it. Oh, it's not there. So we put it there, right? That was pretty easy, right? Everybody get that? All right. So now we want to delete it. So let's suppose we're deleting 4. So just we have to find it first. So you find the 4. Now, everybody eyeball it and think about how we're going to delete 4. I mean, let's start by just throwing 4 away. Now, what are we going to do with 4's children? Yeah, put it under 8, right? Everybody see here, 4, we're really lucky, and 4 only has 1 child, right? So we see, hey, 4 gets thrown away. We throw away 4, and we move in. These are pretty animated. I must have made these. I don't think anybody else would have done that. Right? Everybody get this? Everybody sort of follow how we're doing that? All right. So this is, if it doesn't have 2 children, if it only has 1 child, right, then you can delete it and point the parent at the 1 child, right? That was pretty easy. All right. But now we're deleting the 3, and it has 2 children, right? So that's a bit of a problem. And what are we going to do, right? Because now the under 2 could be this big tree, right? And under 11 is this big tree. And we're deleting something, and we want it to be gone, right? We could say, hey, there's nothing here, but we want it to be gone, right? Do you have a question or thought? All right. So what we're going to do, I mean, this is a fun algorithm anyway, and this was an algorithm I got with part of the homework assignment, was given a node, find the next node in the order. All right? So if you eyeball it, who's next after 3? It's 4, right? But how do you find them? Right? And in this case, everybody bigger than 3 is going to be in 3's right tree, right? And if you kind of go, if we went up this way, then these guys are even bigger. So we want the next guy. So the next guy is going to be in this right tree. Can you kind of buy that, right? If now 1 is smaller, but suppose this tree went this way, right? Then this root here would have to be bigger than all of these guys, right? It would have to be 13, and then these would have to be even bigger. So we do know that the next guy is over here, right? So we move over here, and now what are we doing is we're effectively looking for the smallest node in this subtree, right? what does next mean? It's the smallest node that's bigger than 3, right? So you go bigger than 3, and then you want to go small as possible, right? And how do you go small? Is you go left, right? So you go left, 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 until you can't go left anymore, right? So what's the joy about it? Happens to be 4, which is an integer bigger than 3, right? But we know, what do we know about this 4? Well, it's bigger than 3 because it's in the subtree, and nobody in this subtree is smaller than it, right? You go up this way, these all are going to be bigger. You go right, these all guys are going to be bigger, right? In some ways, right, it's the leftmost in this subtree, right? If you think left to right. Everybody kind of buy that this is our biggest, is our next guy? It's our smallest in the tree, right? So you might want to remember this algorithm. It's a good little algorithm. Go right and then go left until you get stuck, right? And you can imagine me making you code this up, right? Everybody good? All right. Now what are we going to do with this 4? Suppose I don't like 4. Can I delete the 4? How would I delete, if 4 was what I wanted to delete? Exactly. He's right, right? Why was the deleting easier before? Was because you only had one child, right? And 4, why does 4 only have one child? It's because we went left till we got stuck, right? So kind of by how we found 4, we know that 4 doesn't have a left child, right? And hence, we know how to delete 4, right? And so that's what we're going to do. We're going to go right, left, left, left. We find 4. And then what's great about 4? It has no left subtree, right? So then we're going to delete 4. What are we going to do with 4? Oh, we're going to put 4 where 3 is, right? 3 comes out, 4 goes in. Everybody good? And that's okay because we just put the next guy in that spot. And then now we have to attach 6. So 6 attaches. Yeah? Yeah, this is kind of what I was saying is this tree could be really big, right? I'm only drawing the parts that we're paying attention to, right? Let's assume that 2 has some really big tree, right? And 1 has a really big tree. So does that help? What was your, sorry, say again what your solution was? Yeah. Yeah, so there are 2 things wrong with that. The first off is on 1's left side has to be smaller than 1. So 2 doesn't belong there. That's the one problem. And the other problem is, as I kind of said, this is just a clean example. Really, there's going to be a big tree under 1. They're going to be, assume that we got everybody has, it's big, right? So, right, 1 has children and 2 has children, right? So you can't, we don't know where to put things. So should we review that algorithm again? Right? So what we're saying is 2 can't go up here because it's bigger than 1. Besides, 1 has a lot of stuff up there, right? And we have a lot of things under 2. So 2 is a big tree, 11's a big tree. We don't know what to do with these big trees, right? So we find the next guy. How do we find the next guy? We go right to get bigger, left, 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 left to get smaller. We find the 4, right? Then what do we do with the 4 is great because he has nobody on the left. Then we take the 4 and we put it where the 3 is, right? And why is this valid to put 4 here? Well, 3 was bigger than the 2 and everything, and 4 is even bigger, right? So 4 is happy with that, and 4's smaller than everybody in this tree, right? Why? Because we chose 4 to be the smallest in this subtree, right? Everybody in this subtree is bigger than 4. Why? Because 4 was its smallest, right? So 4 really can sit between 2. 3 sat between 2 and 11. 3, it was so close to 3. 3's gone. 4 can sit there, right? Everybody buy that? And then what do you do with the 6? Well, there wasn't a left, right? So the 6 can move up there, right? And 6 before, 6 is in the left subtree of 8, right? So everybody here is smaller than 8. And you move it up there, it's still smaller than 8. Right? Everybody kind of buy that? And so that was the whole thing, right? So now we know how to insert and delete where the running time is the height of the tree. Right? Everybody good? So now what we want to do is we want to balance the tree. All right? And if it's completely balanced, then it's of height log base 2. Right? But the worst case is pretty bad. Right? And so we're going to